So in this question, you're given that a person starts from the origin and moves 3 units in the northeast direction. That is exactly in between east and north. So he has moved 3 units in the direction that makes pi by 4 with the east direction. And he reached a point A, and from this point he moved 4 units in the northwest direction. And he reached a point P. And you're asked to find the coordinates of this point P. So how can we do this using the rotation theorem? So let us say that the complex number corresponding to P is Z. Now what is the complex number corresponding to A? The complex number corresponding to A is 3 times e power I pi by 4, right? Because this length is 3, this angle is pi by 4, and this is 3 times e power I pi by 4. So now let us consider something like the final vector divided by initial vector. So the final vector is Z minus 3e power I pi by 4. So I am considering this vector. So the vector AP bar is given by the final vector Z minus 3e power I pi by 4 divided by the initial vector BOA. So OA is 3e power I pi by 4 minus 0. So the initial vector is OA bar. That means the direction of the vector is like this and the final vector is like this. So this will be equal to the ratio of magnitudes of final vector by initial vector. The final vector magnitude is 4, the initial vector magnitude is 3. So you have 4 by 3 times e power I times the angle from initial vector to final vector. So initial vector is this, the final vector is this. So the angle is 90 degrees in the counterclockwise direction. So you have e power I pi by 2. So this implies Z minus 3 times e power I pi by 4 is equal to 4 by 3 times e power I pi by 2 is nothing but I times 3 e power I pi by 4. So this 3 and this 3 gets cancelled. So you have 4i times 1 plus I by root 2. That is equal to 2 root 2 times I minus 2 root 2. 2 root 2 times I minus 2 root 2. So this implies Z minus 3 e power I pi by 4. So this implies finally Z will be equal to 2 root 2 I minus 2 root 2 plus 3 times 1 plus I by root 2. So if you take the LCM, finally you have 4i minus 4 plus 3 plus 3i by root 2, which is equal to 4 minus 4 plus 3 is minus 1 plus 7i by root 2. So the complex number Z is this, and the coordinates correspond to Z are minus 1 by root 2 comma 7 by root 2. So I hope you have understood how we applied the rotation theorem. So in this question, you're given that if OZ1, Z2 form an equilateral triangle, you're asked to prove that Z1 square plus Z2 square minus Z1, Z2 is equal to 0. So let us plot Z1 and Z2 on the organ plane. So let origin Z1 and Z2 form an equilateral triangle. That means this side, if it is equal to A, this also have to be equal to A. And the angle between these two has to be 60 degrees. So if this Z1 gets rotated through 60 degrees exactly to get Z2, then OZ1, Z2 form an equilateral triangle. So Z2 has to be equal to Z1 times e power I pi by 3, right? If you rotate Z1 vector by an angle of 60 degrees, You have to get the vector z2. So z2 has to be equal to z1 times e power I pi by 3. This implies z2 by z1 is equal to e power I pi by 3, which is equal to cos pi by 3 plus I sine pi by 3. And this implies if z2 by z1 is e power I pi by 3, what is z1 by z2? z1 by z2 is e power minus I pi by 3, which is equal to cos minus pi by 3 plus I sine minus pi by 3. Now what happens if you add these two equations? So you get z2 by z1 plus z1 by z2 is equal to, if you add these two, sine pi by 3 minus sine pi by 3, these two gets cancelled. But cos minus pi by 3 is same as cos pi by 3. So you have 1 by 2 plus 1 by 2 is equal to 1. This implies if you take LCM, z2 square plus z1 square is equal to z1 z2, and this implies z1 square plus z2 square minus z1 z2 is equal to 0. Hence, the result is proved. Thank you.